Today, there is global attention on CCUS technology, which captures, utilizes, and stores emitted CO2 as a means to achieve carbon neutrality. NEDO, under the jurisdiction of the Ministry of Economy, Trade and Industry, has initiated various R&D and demonstration projects aiming for the social implementation of CO2 capture and storage technologies around 2030. Japan CCS, under the commissioning of NEDO, is conducting the Tomakomai CCUS demonstration project. Now, let us introduce the world's first demonstration test for transporting liquefied CO2 at low temperature and low pressure, newly commissioned by NEDO. Recently, technologies for capturing CO2 emitted from factories and thermal power plants have evolved, and technologies for utilizing and storing CO2 have also been developed. A major obstacle in this context is the technology for transporting CO2. CO2 emission sites and storage sites are often far apart, requiring large volume transportation over long distances. Therefore, CO2 ship transportation has become important. To conduct CO2 ship transportation in large volumes, safely and at low cost, a consortium of private companies led by Japan CCS has been commissioned by NEDO to carry out this R&D and demonstration. Transporting large amounts of CO2 in its gas state is difficult due to its large volume. Therefore, it is pressurized and liquefied for transportation. However, lowering the temperature and pressure of CO2 to approach its triple point increases the risk of dry ice formation, so it is necessary to manage this risk appropriately. The key points of this R&D are to identify the optimal conditions for each process, including CO2 liquefaction, storage, and ship transportation, in order to transport CO2 in large volumes safely and at low cost. The Maizuru Terminal in Kyoto Prefecture. First, the CO2 captured from the thermal power plant is received, and the CO2 gas is liquefied. It is stored temporarily in a tank to stabilize the temperature and pressure, and then loaded onto the demonstration ship. The CO2 transportation demonstration ship, X-Cool, was completed in 2023. X-Cool is equipped with a cargo tank system developed in this project. This ship has a total tank capacity of 1,450 cubic meters and can accommodate temperatures ranging from -20 to -50 degrees Celsius. After leaving Maizuru, X-Cool heads for Tomakomai, Hokkaido, some 1,000 kilometers away. The Tomakomai Terminal in Tomakomai, Hokkaido. The CO2 transported to Tomakomai Terminal is unloaded and stored in a liquefied CO2 tank. Afterwards, it is reloaded onto the demonstration ship and transported back to Maizuru. This process will be repeated, and by identifying the optimal conditions for not only the ship but also loading facilities and storage tanks at the onshore terminals, the project will lead to the development of large volume transportation technology. This R&D aims to provide a new low-temperature and low-pressure transportation option, in addition to the existing medium-temperature and medium-pressure option. Transporting CO2 at low temperature and low pressure can achieve various benefits. As the pressure is low, it is possible to make a larger tank using the same plate thickness. The site area can also be significantly reduced. Likewise, a ship can be equipped with larger tanks. This enables a larger ship size, reducing the number of voyages and transportation cost. On account of these benefits, the results of the world's first demonstration of liquefied CO2 ship transportation at low temperature and low pressure are highly anticipated. Through this project, we will contribute to achieving carbon neutrality by 2050.